Okay, so let's talk about how we're going to do mole to particle and particle to mole conversions. So over here, this is just to remind us the names. So if we have one particle of an element, we call that an atom. That's the name of our representative particle. One particle of a covalent compound is a molecule, and then one particle of an ionic compound is a formula unit. It's just to remind us what the names are. So here we're going to go from moles to particles. So we're not going to use molar mass because this has nothing to do with mass, but we're going from moles to particles. Anytime it's moles to particles or particles to moles, this kind of conversion, we're going to use Avogadro's number, or like you guys like to say, avocado's number, okay? And that is 6.02 times 10 to the 23rd. Remember, it's just like there's a dozen. Use mole is like dozen. So if I wanted to know how many dozen particles of sodium fluoride I had, it would be 12 per dozen, right? But I want to know, but I have moles, not dozens. So I have to use this number per mole. All right, so what did we get when we put this in our calculator?
I got 3.64. I got 9.64. I got
1.6 times 6.022. Because I want to make sure everybody's using their calculator correctly. You should get 9.64, because I'm rounding up, times 10 to the 23rd formula units of sodium fluoride. And yes, it's okay to write FU as our abbreviation for formula units.
You have to write like the sodium fluoride.
That would be good practice to do so, because when we get into our next unit, when we do stoichiometry, we're not just talking about one thing. When we do a problem, it could be lots of different things. Okay. Number 2, how many moles contain 2.0 times 10 to the 24th atoms of silver? Okay, 2.0 times 10 to the 24th atoms of silver. And we want to know moles. So we're going from atoms to moles. Do you hear the word mass in there? No. So we're going to use Avogadro's number. It doesn't have anything to do with mass. So what's going to go on the top?
There will be like 1 mole.
1 mole has to go on the top so that you can have atoms on the bottom, because it's going to be 6.022 times 10 to the 23rd atoms per mole. So that our atoms cancel. And everybody do that in their calculator and make sure that you're getting the right answer. Yes, 3.3 moles of silver. So when you're trying to get moles, moles has to go on the top, so that's the unit that you get. When you're trying to get particles, the particle has to go on the top. Okay, so on this next one here, how many representative particles are in 15 moles of lithium? Well, I think you know how to do this. 15 moles, and you're going to have Avogadro's number on the top per mole. But what is the name of the representative unit? Atom, right.
Why is it spelled MOL?
That's the abbreviation for mole, because it saves us a lot of time, right? Because we only... Yeah, exactly. That's just the abbreviation for it.
So I could just keep spelling moles. So
if you wanted to, that's absolutely fine. So you should get 9.0 times 10 to the 24th atoms of lithium. Okay, are we kind of getting how to do this one?
Yes.
The key is to look at the problem and see what's being asked for to know whether you're going to use molar mass or whether you're going to use Avogadro's number. Because it's an element. Because of this right here. Because lithium's an element, right? Lithium's an element, so an element's name is an atom.
Oh, so it's like a...
So if it were like... Yeah, if we look down here at number 6, number 6 says how many representative particles are in 1.5 moles of ammonia? Ammonia is a covalent compound, so our answer would be in what? Molecules. So the answer for that one would be in molecules. All right, so I'm not going to do any more on this one. This was just our practice to see how to do it, although I will finish it and post the key to this one. But let's talk about, no, that one we were on is not homework. This one right here that says moles, molecules, and grams worksheet practice, mixed practice number 1. Whew, that's a long name. This is your homework. So let's look at these because they have problems like the ones from the other day and problems like we just talked about. So the most important thing in the beginning is to figure out what kind of problem it is. So let's look at number 1. How many moles are there in 24 grams of iron 3 fluoride? What kind of conversion am I going to use? I need to look at it and say, okay, am I going to use Avogadro's number? Or am I going to use molar mass? Yeah, I'm going to have to use molar mass, right? Because it starts with grams. So I got to go from grams to moles as opposed to particles to moles. And then since it's a compound, I would have to figure out what the molar mass of iron 3 fluoride is.
You put that on the bottom?
You would have to get it to cancel.
Wait, but wouldn't you end up using both of them like that one again?
Not because it only asks for moles. So it's just a one step. But eventually, so this right here has some of both of them in there because this one goes from grams to moles. This is formula units to moles. Formula, there's no mention of grams in here for number 3.
Oh, okay, so like you would do.
So that's going to be Avogadro's number.
If you use both of those, you have to go from grams to atoms, molecules, and then.
Yes, like I'm just flipping this over and looking at number 8. So we can see what Brooklyn's asking about. Flip it over and look at number 8. Number 8 has grams and particles in it. So what are we going to have to do to solve number 8? Well, you can't go straight from grams to molecules. You start with molecules, right? You can go from molecules to what? Moles. So you'll go from molecules to moles, and then you can go from moles to grams. So it's going to be a 2-step problem, kind of like, well, I mean, it's not going to be the same way we did it in our little mini lab we did, because that went from grams to molecules, but it's kind of going the opposite direction. Does that make sense?
Yeah.
Okay. Now, some of these problems on the back, especially like the last 2, I just want you to give it a try. Just think about it. I don't want you to spend 3 hours on it. I just want you to do your best and try it. Try something.
So that's our only homework.
This is your only homework. Okay? If you need, okay, I'm going to end the video and we'll post this.